Hi everyone, I'm Karina Kondorova and I'm Director of IT in IIS. Welcome to your first virtual workshop. In this workshop, we'll be learning about R. Just a disclaimer that data science is a huge field, so there's no way you can learn about it in a single workshop, not even taking a single class. Data analytics has changed everything, from understanding how one data point is connected to another one, or basically what is their relationship, to uncovering patterns and understanding people's behavior. But it ended up by making a large-scale business decisions, and those decisions could be risky, but they can give you a high return because you can uncover something that never existed in the market, and that's what people wanted. So R is one of the top 3 tools used for data analytics in the statistical programming framework. And it's used everywhere, in finance, in marketing, in sociology, environmental science, chemistry, physics. I would say everything. I could keep going on and on. It has a set of statistical tools called packages, and they allow you to analyze data more efficiently and uncover patterns and trends in the dataset. The goal of this workshop to give you a basic understanding of R. If you like it, you can continue exploring it more, but that's just giving you basics, and then you can continue from here. About R. So R is programming language for data analysis and statistics. It is free, and it's widely used by professionals. It has built-in functions and libraries, and we talk about thousands and thousands of functions that can give you a lot of functionality and flexibility to analyze your data however you want. And lastly, you can create your own functions. You can create your own packages because all of these packages available in R were created by people that don't even work in R. So, how do you analyze? What is the process of analyzing data in R? You first import data, say in a database, or you import it on your computer. Then you have to prepare it. The way you prepare it is you organize it, you make it structured. So you put it in Excel file or CSV format because R can only understand structured data. And then you put it in R. And then you start data wrangling process where you select data, which one you want to analyze, and then you delete data or you change the format of it, all the fun stuff. And then you start analyzing it by applying statistical tools to it. And if you want, you can visualize it, see if you like it, how is it the result you wanted. And then you continue, keep going this process over and over again until you get the result you wanted. And in the end, you present it. You present it to stakeholders or whoever you were creating it for. And I hope this workshop will be beneficial for you and will give you a lot of fundamentals and basic stuff for you to understand what is R, and I hope you'll enjoy it. So you downloaded this file, F20TD Workshop 1 R. We're gonna unzip it. And I'm gonna sort it by name. So inside the folder, you'll see 2 folders, data, where we have all our data set that will be loading in R, images. It's empty right now. And exercise R, lecture R, and workshop 1 R project. So this is our project file. And what it does, it creates the environment where it sees all of these files. So let's open that. So here's our studio. The layout is on the upper left window, you have our script. Below it, you have console where you'll see all the output. Upper right window, you'll have environment where you can see existing variables and what each contains. And below it, you have tabs for files and plots that we'll be creating later in the workshop. So what is R script? It's an R code file where you write code and then save it to run it later. Right now we have lecture.r open. Whatever is .r is an R script. If you do not have it open, go to Files and Lecture. So let's write some basic code. We'll start with creating headers. Right here, you can see there are some already pre-created. If you don't see it, you can click a little lines here and it will open up. You can also see headers here, top level, and then you can move around here too. The way you write them is you put the hashtag, say, let's write header 1. Put one hashtag for header 1. You'll write something. Let's write just header 1. And then 4 symbols after that. And then you can see header 1 is here. It is better to have more than 4 symbols. Like that. Because when you move around the code, you can see different sections. You write header 2 by putting 2 headers, two hashtags, and then you capitalize H for header, and you capitalize 2. And then I'll copy that. To write the header 3, you put 3 hashtags, you just capitalize H, but you will not capitalize 3. And for header 4, 4 hashtags, no capitalization. Paste it. So here you can differentiate between header 1, header 2, header 3, and header 4. That's why we write it in this format. You can write it in your own way, but it would be harder to differentiate between them in R. So let's write some basic code. Let's write hello world to the console. To do that, you use print function, open brackets, and you can see it pre-created the closed ones, open quotation marks, hello world. Now to see the output, you need to run it. You hit run here, or there's a shortcut, which is Command return for Mac and Control Enter for Windows. And you can see hello world. Let's create a variable and then assign 10 to it. The way you create new variables in R, you do not do var like in JavaScript. You just write a. And then in R, equal sign, you can use equal sign, but it's more common way to use arrow, which means get. So whatever before arrow, R understands that this is a new variable. And we'll write 10 and run it. So how it reads, A gets 10. You can see that variable A, it has 10. Now, because R understands that whatever before the get symbol is a variable, if you call it again and then assign, say, 11 to it, right now we have 10, and if I run it, it replaces the value A with number 11. We can also assign one value to multiple variables. The way you do it is, for example, B will get whatever C, and C will get what's in D. And then the last will put 1, say. So B will get whatever in C, and then C will get whatever in D, and D will get 1. And we'll run it. You can see B has 1, C has 1, D has 1. The console will just send confirmation. You can also assign multiple values to a single variable. So the way you do it is, first let's create a new variable x. And then you can use C function, which reads as combine, and we'll combine 1, 2, 3, and 4. And then let's run it. Now you see x has numbers 1 through 4, and these are indexes. So let's call the same variable, and then let's call it, and then we'll use a second index, whatever in the second place of this variable, and run it. So number 2 is in the second index. We can also call whatever is in the first index. Number 1. Another way to do that is, let's create variable y. It will get combine functions, and then it will place 1 through 10. And we'll use colon sign and run it. Now y has integers this time, 1 through 10, and you can see. And if we call y and index 4, number 4. 1, 2, 3, 4. There's another way to do that. There's also, let's create number z gets, there's a function sequence 10. But what it will do, it will write into z a sequence 1 through 10. We'll run it. You can see it, also integers, indexes 1 through 10, and numbers 1 through 10. And the last method is, let's assign to value w, and it will get a sequence of, it will start with 10, it will end with 1, and it will reduce each number by 2. And we'll run it. Now w has 10, 8, 6, 4, 2. It didn't end with 1 because 2 minus 2 will be 0, but we asked the least number 1. So let's do some math. R can calculate math for you. The way you put the numbers in is the same way you would put in the calculator. So let's do 2 plus 2. And the output will be in the console 4. We can assign that. Let's do a gets 2 plus 2. Right now a is 11. I run this, it will be 4. But in the console it will be just a confirmation. Subtraction will be 2 minus 1. Run that, will be 1. Multiplication will be 2 times 2 is 4. Square root has a function for it. Let's do 4. And square root of 4 equals 2. And then logarithms. Log function. 4 for x, and then base will equal 2. The output is 2. R is very famous for having a huge library of packages that are free. These packages have a set of additional functions that will help you to analyze data more effectively and efficiently. The base functions that R provides is not enough, so you'll end up downloading packages. To learn which packages R provides, you can go to cranrproject.org, and then on the left-hand side, you see software, and there's packages link. Let's select table of available packages sorted by name. And as you can see, R has a huge selection of packages. They provide a little description about that, but let's search for read Excel. Here it is. That's the package will be imported. Little description: import Excel files into R. We see the versions, and we also have a README. And then it has overview, how do you install it, how you use it, all the information you need to know. So let's install it. The way you install it, you use install.packages, and you can see a little window guiding us. So let's hit tab. And then right now, Excel doesn't know about this package, so we'll just send in a name, read Excel. This is just a string. And then let's run it. You have a prompt window asking you, do you want to restart R prior to installing? Yes. It will back it up. You will not lose anything. And here's the message that it has been installed and which folder is it. I will need a couple more. So I will need psych. Let's run that. And then while R is installing the package, I'll run another one. I'll need a tidyverse. And then run that. It said, okay, install. And then right here, icon, but stop. Well, I don't see icon here anymore, so that means it's done. So since it's been installed, now I have to activate it. Every time you run RStudio or a new script, you have to activate those packages. You don't have to install them. So we'll write library function. And now, without quotation marks, we will write a package. Because R already knows about it. We'll activate that, and then I have library psych. I can hit tab, and then I have library tidyverse. Activate that. So I see a confirmation message that package has been installed. You can also install packages from Packages tab and click Install, and you can search them from here. But if you are sharing RScript with someone, it is better to include the code in RScript. So the person you're sharing to will install all the packages, will activate them, and will not have any issues running your code. R has pre-uploaded datasets available to analyze. They are already structured and ready to go. To list all datasets that are available as part of R, we'll write library help and then datasets. So we're asking like which datasets we have available, and we'll run that. So here you have a new tab, and then here's index, and these are the names of packages, and here's the description of them. And you can see that's a huge library. So to import one of the datasets, use function data. So let's import UCB admissions, which is the Berkeley admissions datasets. So we'll write data and then University of Berkeley. And then run that. If you want to get some more information about the dataset, it could also be used for packages or functions. We can use question mark. And then let's do about admission. It already understands what I want. And we'll run it. So under help tab, we can see additional information about it. In real life, you import your own structured data to R. You can import many formats using, say, read, and then there's many functions. There's CSV, but we'll use read Excel. This function is under read Excel package. So we'll open quotation marks. We first need to select this folder because the dataset is under this folder. We'll do data, and then the actual package, SB Excel SX. Run it. So this is the output confirmation. It just read this file, but we want it to be here. So what we're gonna do, we're gonna say get, then let's create a new variable called data frame, shortly df. It's a more common way to put a data set in if you have only one data set. If you have more than one, then just create new variables and pick a name however you want. And then if I'm gonna run that, so df gets read Excel from data and read this file. And whatever the output is, put it in df variable. So we're gonna run that. And now we have, under data, we have df file. And then you can click here and you can see the whole file. We have date, open, high, low, close, adjusted, close, and volume. Notice it says 61 observations. That's a number of rows. And then 7 variables, it's number of columns. R has a different language and names for that, but that's what that means. I have here 61 rows and 7 columns. So now we're done with our basics. We finally learned the basics, how we write basic code, and how do we assign, how we create new variables. We do not use var. Instead of equal sign, we use a arrow that points to the left. And then after arrow, we put either function or a number or a word that we want to assign to it. So under environment, we don't need that anymore. So this code, this one, is already given to you. So what it's gonna do, it's gonna clean up the whole environment. So let's run that. And then whatever is in the console, we don't need that. So a shortcut will be Control L for both Windows and Mac machines. So I'm gonna run that. And console is clear too. So since we ran this code, it actually cleared environment, and now R thinks that this is a new session, so we will need to activate these packages again. We do not have to install them because this code just makes R think that this is a new session and it didn't delete any packages. Now we're getting to data visualization, and I need one more package for it. Let's install it. All right, install packages, and it's called ggplot2. I'm gonna run that. Yes. ggplot2 gives more functionality for data visualization. It is easier to manage data and move it however you want with this package rather than with base data visualization code. So I'm gonna show you the base code later. More professionals in the field who do data visualization actually use this package. So now it is installed, and I'm gonna activate that. Library ggplot2, remember without any quotation marks. We already installed it and R knows about it. Now it's ready. So for data visualization, I will need to load data. So I will first load SMP like before, but remember, we cleared the environment. We're gonna start over. I'm not gonna do df because I'm gonna have two packages, two data sets. I'm sorry. First one will be SMP. SMP gets read Excel, and then open quotation marks, data folder sp Excel SX. Run that. Could not find function read Excel. This usually happens when a package has not been activated. We activated it, but let's do it again. And just in case, I'll do 2 other. Okay, let's try it again. There we go. I can see in data, SAP is here. And I have one more package, it is Amazon. So I'll create Amazon get read Excel, and then data folder Amazon.excel excelSX. I'm gonna run that, and I have it here. You can also use this function to read CSV. As you can see, I have CSV format. I will not use CSV, but I'll show you. Let's do just call it CSV gets read, and this time I'm gonna do CSV. I'm gonna do data folder, and then I'll do Amazon.csv. Gonna run that, and it ran. It's right here. You notice that the way it read data, it is a little bit different. So from Excel, the date is not in date format, but in CSV, it's in date format. I'm gonna use Excel, and I'll run a code to specify the date is the date. But you can see that CSV also it can read CSV, but I don't need that. So I'm gonna run a code to delete CSV from the environment. It will be just remove rm and then the name of the variable, CSV. I'm gonna run that. There we go. It's been removed. Now we'll be doing plots. So beforehand, I want to assign all the plots to images folder and name them how I want, and in PDF format, and then I will assign it to new variable that will hold the location and the name of the plot. So let's do first for Amazon SP plot gets images Amazon SP plot. This is just a name .pdf. I'm gonna run that, and here it is. It has the folder, it will have a name. We will call this function at the end when we're gonna do all the plots for Amazon and SAP. And also we'll have SP plot gets also images. Let's just copy that. Images, and then let's just remove Amazon from it. And let's just copy that and do for Amazon. And then I'm gonna call it Amazon. And I didn't run this code. I'll run that, and now I'll run that. It's under values. I have Amazon plot, Amazon SAP plot, and SAP plot. Now it's ready. Everything is set up, and now we have to do some filtering with data. So let's do some data filtering. If you look at the dataset by colon Amazon, we won't need open price, high, low, close, and volume. We'll just need date and adjusted close. So how I'm gonna do that? I'll use select function, but first I will call this variable that holds this dataset, because R will replace the values by just selecting date, by just keeping date and adjusting close. So I'll call Amazon gets, and then I'll use select function. First, I have to select the dataset again. It's Amazon dataset, and now I'll be selecting, as you can see, 3 dots. I'll be selecting columns that I need. I need date, adjusted close. There we go. Instead of 7 variables, I just have date and adjusted close. The same thing I'll have to do for S&P. So I'll do SP, call the variable again. I'll select SAP dataset, I need date, and adjusted close. R is case sensitive, so make sure you write correctly, like how it is. otherwise it will not understand what I'm asking for. For example, I will, instead of capital C, I'll have small c, and it will say, I don't know what's going on. Such column doesn't exist. As mentioned before, that when R read Excel, it assigned a different format instead of date. So since we have date in our data, we will need to tell R that this is date. R needs to be told that this is a date format because most of the time it assigns date as integer or string. In our case, this is the different format. And it won't be used in graphs and charts because R cannot recognize the format and it will return error. So we will call Amazon dataset or variable, but this time we will select specific column that we want to work with. By using $, we're selecting date column, and that will get whatever the function will do. So we'll use the function as date. I will call this dataset again, and I'll select date column again. And this is the format I want. Open quotation marks, percentage, month, slash, percentage, date, and slash, percentage, year, capital. And then for time zone, it will be, in quotation marks, Eastern. I'll run that. And now instead of SAP has still this format, but now it's a date format. So we'll have to adjust SAP too. SAP select date, gets as date, select SAP again, select date, column, format, percentage month, percentage date, and then percentage year, capital, and then time zone, Eastern. I'll run that, and now it's a date format. So now our data is all set for data visualization. So let's create a line chart. We will create a new variable called Amazon chart and start with writing the code that will create the line chart. Amazon chart gets. Now we will use ggplot2 package that we installed previously, ggplot2. So I'll call it, but without two number, just ggplot. ggplot is just a base. It provides fundamental level or base level for additional code to use that information and create data visualization. I'll show you later. You'll understand. So for that, I will need Amazon variable that contains Amazon data, and then IAES. It's called aesthetic mappings. Open parentheses, and it guides me at what should I put for X and what should I put for Y. For X, I need to put date, and for Y, I need to put adjusted close. That's it. So what it does, it selects this dataset, this variable that has Amazon dataset, and then it will select from this dataset and put date for X and then adjusted close for Y. But we're not done yet. The last piece of code is plus and specifying which type of chart do we want. And we want geom line, which will create for us line chart. So think of it as layers. ggplot as base function gives us dataset, X and Y. And then on the top of it, we specify which chart type we want to do. And then the rest will be titles, labels, and etc. We will save that. Now, Amazon chart, we don't see it yet because all the information has been transferred to this variable. So we can call it. Let me copy that and then paste it and call it. Now here's the line chart. And we can even zoom in. And here it is. So as mentioned before, we'll be saving this variable to a PDF file. So we'll start by writing PDF function that will start a process of creating a file. And we'll use this variable. Copy that. So what this process will do, PDF will start creating a file by using this variable. But this variable has a location or a destination and then a name of a PDF file that we want to create. I'll go to Files, and then I go to Images folder, and right now it's empty. So I'm going to run that. And here it is. The same name, which folder, but it's empty right now. Right now what it does, whatever I'll put here down this code will capture it. And it will continue capturing until I'll write a code to tell it stop capturing and end the process and put it in the file. So I'm gonna copy this variable and put it here. I will run it. So now PDF file knows about this chart. It remembered it, and now we're gonna send it away. Div.off, and I'm gonna run that confirmation, and now if I open that, I have a plot in a PDF file. Now we'll have to repeat this process for S&P 500 chart. I'll create a new chart variable, S&P chart. It will get ggplot function. It will take S&P variable that contains dataset. And for aesthetics, you can specify that X will have date and Y will have adjusted close. And then using this base function, we will create a line chart. I'm specifying that I want a line chart. I can highlight this code and run it, and it will run only this code. Or run it all together, and it will not create this graph. It will just send this data to this variable. Now I'll have to save it. Same process with Amazon PDF, and pre-created variable that has destination and the name of the file. Copy that. Now we started this process, and then I will copy this variable. I want it to be in the PDF file, and finish it with sending it away and ending the process. I'll go to Files, and here's the plot. Let's get a little bit more complicated. Let's combine them together. Let's create first a new variable, Amazon SD chart, and it will misspelled chart, and it will get, first we'll put ggplot, and we'll only use Amazon variable that has Amazon dataset, and we'll set up aesthetics. I'll use date and then adjusted close. Then I want to specify that I want to have a line chart. A little bit different I'll do this time is I want to create a legend that with this aesthetics, it will have color, and the name of it will be Amazon. And then I'll have to add another line with S&P chart. So I'll do data will be SOP. It will use X and Y the same as Amazon. And then aesthetics, I'll create a label or a legend for it. It will be color equals SP500. And then last, I need to name a legend. It will be labs color equals stock. Let me cut that and run this code. And here it is. We used our base function ggplot. We selected data, dataset, aesthetics, and then base for X, adjusted close for Y. We specified that we want to have a line chart using this data, aesthetics, and then for color, we'll just name it Amazon. So whatever color it got, we will name it Amazon. And then we'll add another line. This time it will be for S&P. We specified that this is S&P dataset. And then for X and Y, since this is a base function, it assumed that date will be X and then adjusted close will be Y. And then whatever color it got, this time it's like bluish color, we'll name it S&P 500. And last, we created a legend and named it stock. So now let's save both of them. Same process, PDF, and then let's go up. We need a name for it, Amazon S&P plot. It started the process. I also forgot to give it a name. Well, I cut it, but it was Amazon. And then S&P chart. And then I get gets. Alright, so let me run that. It has our information, and then I started PDF form, PDF session, and then I'm gonna call this chart, this variable again, run it, and then I'm gonna send it away. There we go. So let me go to files, and here it is, our line chart. Let's build histograms. Before I do that, let me show you Diamond's dataset that I'll be using. And as you can see, I have pop-up window. That means that R knows about Diamond's dataset because it was pre-uploaded when we downloaded Tidyverse package. I'm gonna run that. For histogram, I'm gonna use price information. I'm gonna use HIST. This is a function that came with R. Now I'm gonna select diamonds and then select price and run that. As you can see, this is just a basic plot that R built for us. And if you want to do a quick plot, you can use this function. Sometimes you can do just plot function and then his diamonds and price. So this plot function, what does, it will select the best plot for your data. And it picked completely different chart. We can add some formatting to that. Let me remove this plot. We can add colors to this plot. Before I do that, I'll show you colors that R knows. I'll run colors function, and this is the list of colors that R knows. But it's hard to differentiate between them, like light pink 1, light pink 2. So there's a website for that. I'll do browse URL, open parentheses. And then I'll do HTTPS. datalab.vc r colors. And I'm gonna run that. So this is the website. So this is a website, and it tells you everything about colors. It tells you all the ways you can write colors. You can specify a name, you can specify hex number, you can specify by red, green, blue, and you have to specify that maximum number is 255 a different way, and then you can use an index number. I'm going to show you all of these ways. I'm going to write histogram, diamonds, select price, and then for columns, I want to have colors, and then 646, and I'm going to run that. So it's a little bit better. Instead of gray, we have some colors to it. The second option is I'm going to copy that. I'm going to paste it. And for columns, I'm going to use a name, which is Azure 2. And run that. A third way, I'm going to copy that, is using hex number 2F3293. Run that. And I can also use multiple colors. So instead of this, I'm going to do combine function, and I'm going to copy this number, comma, and I'm going to do Azure 2. And run that. And I can add more and more colors. Let's do white. Got the idea. So now let's create a histogram using ggplot package. So I'll start with ggplot. Base function, I will specify that I want to use diamonds dataset, aesthetics, and for x-axis we'll have price. And I will add geom histogram. And I'm going to run that. I didn't specify a bin width, so it's automatically used 30, but I can do bin width 1500. Let's do 100. As you can see, it's more accurate. We can see an outlier. We can also add some colors to it. Let's do color equals, and I will copy this one. And it's a little bit better. And one more perk about this package is that I hit enter because it will be long. I'll do plus and then theme. It has themes like classic, dark, get, gray, light. Let's do light. I'm gonna run that, but it said nope. Let's do minimal. I think because I specified the color. Okay. I think it will not understand that this is part of this. There we go. Let me try again. It was light. It probably did have some difference. I don't see it, but you get the idea. And then a good thing about this package is that it's so easy to add stuff to it. As you can see, I specified which chart I want to do. I specified which theme, and if I keep adding plus and plus and plus, I add in layers to it, and it works better, because with regular, I will have to put a color inside. I don't have option to add, say, like theme to it. And then if I would want to add another histogram, that would be way more complicated code. So I will add, this time I'm gonna call it again. And I want to add cut to it. So I want to see what type of cut will I get under specific price. So I will use ggplot again. I will copy that. And then I'll do geom histogram again. And I will, this time for aesthetics, I'll say use these bins, use the x-axis and y-axis, and we will fill it with cut. Let me run that. So you can see, so based on the price, we get what type of cut we will get. And I can also specify bin width. Equals 1500. It said no. Oh, it has to be outside. That's why. There we go. It's a little bit better. So as you can see, it's so much easier to specify which chart we want and then what we want to add to the chart. So let's continue to bar charts. Let's do plot function. I mentioned it before, but if we want to do bar charts, we can use plot or we can use bar plot function. Let's start with just plot, and we will do diamonds, and we will use cut data. And you quickly can visualize it. You can also use bar plot. And then it's a little bit complicated, so I will need to create a table. And then I will have to select from diamonds, and I want to select clarity, comma. For columns, I want to have a color, this color. And then I don't want to have any borders. So border equals NA. Let's run that. It looks so much better. I can also add the names of each y-axis and x-axis. So I'll do title xlab equals clarity, and ylab equals frequency. And here it is. Okay, so I added that. Let's do a bar chart for Amazon stock. First, I will write bar plot. I'll select Amazon, select adjusted close, and then let's see that. Okay. I need a little bit more. So I will need legend equals row names. And then for row names, I want to have Amazon, select adjusted close. And then for x-axis, I want to have a name of stock price. Let's add name to it and store the information there. So I'll call it Amazon bar chart. And then we'll get the information from there. And then now I'll add labels. I'll use text function. For X, I will use this variable. And for Y-axis, I will use Amazon, and I'll select adjusted close. And then if I run this, it's ugly. So let's fix that. First, I'll take all of these labels and I will round the price. So I'll do Amazon, select adjusted close, and I want to round to digits equals 2. Let's run that. You don't see any changes. Added something more. Let me run it again. So I have to fix that. It's too big and it's on the top of each other. So I'll add which side I want it to be. Let me remove that one and then run both of them again. As you can see, it's a little bit pain. You should do both charts if you use basic code. And I need to adjust it a little bit to -0.2. And then I want to have color of blue. Let's run that. Let's remove everything and then continue doing 0.4. And then I will turn it to 90 degrees. Okay, this should be fine. Oh, run it again. This should be final. There we go. We changed the size, we changed position, we changed the rotation, and it looks so much better. So let's create bar charts using ggplot2 package. I might be even misspelling this, so please forgive me. So I'll do basic function, and then I'll specify that I want to have Amazon for dataset, and then for aesthetics, I'll have date for X, and then adjusted close for Y. And I'll specify that I want to have bar charts, so GOM bar, and for some reason it will not run unless I'll specify that stat equals identity. And it basically says like count how many times you had adjusted close under each date. I'll run that. So it's a little bit thin. Well, it's very thin. So we gotta fix that. First, I will adjust width with 15. It looks much better. But I want to change the color. Let's do steel blue. And then run that. And definitely, okay, right here. It looks better. I can keep adding stuff to it. So let me add text, GOM, and I'll do text. I'll start adding labels to it too. Static, I'll specify that this is a label, and then I'll explain later. Equals 2. So what happens? For aesthetics, this is a label, and take adjusted close and round it to 2 digits. Comma, and then I'll position as identity, and then I will let me run that. It says argument. I definitely spelled it. Digits. Looks very ugly. So, first of all, I want to change size of the font. 2, and then I will turn it to 90 degrees. Let me zoom in. And then as you can see, it's like on the bar chart. So let me adjust that too by adding age just to 0. So it will know that put it on the top of each bar chart. I can even put 0.1. Let's do negative. And then it will be a little bit higher and it looks even better. So what happened is we used the basic function, we specified which dataset we want to use. X-axis will have date, Y-axis will have adjusted close. We specified which type of chart we want to use. It will not run without saying that count how many times it had adjusted close. We specified that we want to have a width of the bins to be 15, and then we colored it to steel blue. We added labels by doing GOM text function, and then we told that use aesthetics and then add label. It's only one line. So label was applied to X-axis. It took adjusted close and it rounded to 2 digits, and it specified that this is a label. We positioned it on the top, and then we specified that we want to have size 2. We turned it to 90 degrees, and then we adjusted it a little bit because it was next to the bar chart. So last thing left for us is to save it. So I'll start PDF function. I did not create a variable where I wanted to save it. I can actually do it inside as well. I wanted to save it in images folder, and I want to call it as Amazon bar chart.pdf. And then I'll start this process. I do not have to put it as variable. I can also copy this code, paste it below, run it, and then send the information about it. And then finalize the process by writing this code. And I can open this right now, and as you can see, it's here. So let's start with creating scatter plot. I'll start using basic function provided by R, plot. I'll select S&P variable that has S&P 500 dataset, and I'll select adjusted closed column from it. And then this is for X, and then for Y, I'll have Amazon, and then I'll select adjusted close. And I'll run that. So as you can see, as S&P 500 price is going up, Amazon price is also going up. And it has a positive correlation because S&P 500 is basically a market. It evaluates a market, how all the companies doing, including Amazon. It's easier to read such scatter plot when you have a trend line. So I'll start with creating a line, and then I'll add linear modeling, Amazon, select adjusted close, and now I'll add symbol that means as a function of P adjusted close, and I'll run that. Well, now I have, it says positive relationship correlation between Amazon and S&P 500. So I did that, and then let's do a scatter plot using ggplot2 package. So let's create a scatter plot using our package. I'll start with base. I will specify that Amazon is our data set. For statics, date is for X, and then adjusted close for Y, and then I will specify that I want to have a scatter plot. And this is just like this. We can also use our diamonds dataset. I'll use diamonds, and then for aesthetics, for X, I'll use price, and then depth for Y, and then geometric point. I'll run that. Diamonds. It's a huge data set. So it's hard to look at that. We can add something to it. We can say heading equals, and then we'll use a static, and we want to color it. Let's color price for now. Now it's a little bit better. We can also use any other column to change the color. Let's do cut and run that. So it basically will change each dot by what cut it had. So higher dot had a fair cut, and all the ideal and very good cuts are more between 60 and I would say 63. But price, it's interesting that even though you have basically a good depth and then a good cut, a price is very different. So you can buy a good quality for a lower price and good quality for a higher price. I would also want to mention this workshop about statistical analysis. This time we'll use correlation, prediction, and clustering. So for correlation, I will need to install a package. I'll do install packages, and I'll do core plot. I will run that. And then well, it's already loaded, and then I will activate that. Library. Now it's activated. So let's find out what is correlation. I mentioned before that when stock price, S&P stock price goes up, Amazon price goes up as well. So let's run correlation between Amazon and adjusted close and S&P and adjusted close. It's very positive correlation. And then to find more information about correlation and more additional statistical information, we can do Amazon adjusted close, and then S&P adjusted close. I'll run that. So it tells us that correlation is very positive. But it doesn't mean that when market goes up, Amazon will go up, because when the p-value is above 0.5, it's not statistically significant. That means it doesn't matter if S&P 500 will go up or down. Amazon can make changes and they can go up or down as well. Let's continue to prediction. I will use predict function. So what prediction will do is predict the stock price in the future. Let's do linear modeling, and we'll use Amazon adjusted close as a function of S&P adjusted close. We'll run that. And it technically did for each stock price. And we expect a stock price to have $2,811. But since it's not statistically significant, it might be much higher or lower. Now I'll pass to Kevin Publicover to go over exercise with you, and then I'll continue talking about clustering.
Hi everyone, my name is Kevin Publicover. I'm going to walk you through the first part of the exercise for the technical development workshop. So away we go. First, we will have to activate the packages that we used previously in the normal TD workshop because we're using a separate R file than the one we used before. So every time you switch an R file, you have to reactivate the packages using the library function. So I'll do that now. We say library, parentheses, and then tidyverse, Tidyverse is the first one. So I'm not going to run it. I'm going to copy it. And then since we have to do 7 packages, going to paste it 6 times. I think one more. So since I'm lazy, I don't want to, keep on typing library. So I'll do library tidyverse, and then I'll edit the second one, which is readxl. And the third one is psych. The fourth one is ggplot2. The fifth one, is core plot with 2 R's. And then we have cluster. And lastly, we have nbclust. So those are the libraries. I'm going to run them. So you can either run them by hitting this run button at the top. I'll do that for the first one. But since I have a Mac, I'm going to run them using command return. So I'm running and reactivating all the libraries. Next, we're going to import the S&P 500 and the Google datasets. So we do that using the readxl function that is from the readxl package we just activated. First, we will need a placeholder for the data, and we will then write SP and then the arrow symbol, which reads as gets, and write the function readxl and then the file path to the data. So we'll start with SP, and we do the arrow for gets, read_xl, parentheses, and then quotation marks data /SPXLSX. So before I run that, I'm going to do the same for Google. So we'll do Google gets read Excel, parentheses, quotation marks, data /GOOG.XLSX. If I could just spell it right. So I'll move back to the top and I'll run this function, and then I'll run the second function. So now that we have the data in those variables, we're going to do we're going to filter using the select function to select columns that we need to build the data visualization. We will start by calling an existing variable SP that we created in the previous step, and then start using the select function to specify which data set we are using to select the data, and then we will select columns date and adjusted close. So I'll run through with SP first. So we'll do SP gets select parentheses SP for the data set, date for the X column, and adjusted close, which is ADJ close for the Y. And before I run that, I'm going to do the same with Google. So it's Google gets select GOOGLE for the data set, date for the x-axis, and ADJ close for the Y. So I'll move back up, I'll run that, and then I'll run the Google one. So now we're going to assign a date format for the date column. We're doing this because if we don't do it, the charts we'll create in the future will not have dates on them, and the program will return an error. So we first call the data set and select the date using the dollar symbol. Then we will write the gets function, the get symbol, and the function as date, select the data set and column, format the data, and specify which time zone we want. So we're going to start with Google. This time we'll do Google $date gets as period date parentheses Google $date comma parentheses percentage M for month, percentage D for day, percentage Y for year, move out of the parentheses, comma, TZ equals quotations, New York for time zone. Before I run that, I'm going to do the same for SP. So we'll do SP $date gets as date. We'll do SP $date comma quotation marks parentheses M backslash parentheses D backslash percentage, not parentheses, Y. Move out of the quotation marks, comma TZ equals New York. So we'll run the first one. I'll do Command Shift, Command Return. Then we'll run the second one. You will get a warning message saying that they don't know the time zone New York. You can just ignore that. We will still, be able to format it as a date. So next we will create a new variable called Google Chart. And we'll start writing code that will create a line chart. We will use the ggplot function that we activated previously. And inside the ggplot function, we will specify a variable called Google that contains Google data and an aesthetic mapping, which is just the syntax for ggplot. And that will have the date on the x-axis and the adjusted close on the y-axis. Then we'll specify a line chart by saying geom_line. So I'll do this first. So we'll do Google _chart gets ggplot parentheses Google comma AES for aesthetic, and then the x-axis is going to be date, y-axis is adjusted close, which is ADJ close. We'll move out of the parentheses plus geom line to specify a line chart. And then we'll do plus, we're going to add a title to it. So we do GG title parentheses quotation marks and then your name. So I'll do Kevin since that's my name. You do whatever name is yours. And then before I run that, I like to write down the name of the chart down here. That way, after I run it, I can call it to make sure it works. So move back up to the top and then I'll run the first one and then I'll call the chart. And you'll see in the bottom right panel that the Google chart is shown with the adjusted close on the y-axis and the date on the x-axis. So now we're going to repeat the same process for the SP. So we'll do SP chart gets ggplot SP comma AES for aesthetic date ADJ close, move out of the parentheses plus geom line plus GG title parentheses and then your name. Again, I will do Kevin. Before we run that, I'll write the name of the chart down here so I can call it back. So we'll run the first one to the second one. And now you'll see the SP chart down on the bottom right panel. So adjusted close on the y-axis, date on the x-axis. So now we're going to combine the Google and SP line charts into one. So we will start by creating a new variable called Google _SP _chart and assign a plot to the combined chart. Then we will start with a base function that will take the data from Google and that contains the Google data set. And we will select columns date and adjusted close. So I'll do that right now. And that's kind of the first half of this code. So we'll do Google SP _chart gets ggplot parentheses Google, specify the data, AES date for the x-axis, adjust close for the y-axis, plus geom line like we've been doing. And now we're going to set, create a line for Google and put a legend for the color that is only for Google. And then we'll create a line for the SP specifying the SAP data set. So we'll do geom_line AES parentheses color equals Google, specifying a different color for Google. If I can spell it correctly. Then we'll space out of both parentheses. We'll do a plus, and then I will shift down, but you don't have to. This is just so you guys can see the code. I'll index over. We'll do geom_line parentheses data equals SP comma AES parentheses color, like we did for Google, equals SNP 500. And then space out, we'll arrow out of that, plus labs color equals stock. So what this does is this just says, you know, use the stock colors for the lines. We don't care what the colors are. We just want the colors to be different. And then we'll do a plus, like we've did previously, GG title, and I'll do Kevin, you do your name. And then before we run this, I'm gonna write the name of the chart down here so that I can call it back. So I'll run the first one, then I'll call back the chart. And you can see in the bottom right panel, we have a line chart with both Google and SAP on it with different colors. Again, just to close on the Y, date on the X. So now we're going to do the histograms. So we are going to start with a base function ggplot like we've been doing. And we're going to specify the diamonds data set and select the depth column in the diamonds data set for the y-axis. And then we will specify what chart we want to have. And we will use the step-in function to order the histograms, how wide we want the histograms bars to be. And then lastly, we'll have the title again. So we'll start by saying diamonds underscore depth underscore histogram. We'll say gets, like we've been doing, ggplot parentheses data equals diamonds. Then we'll put a comma, do AES x equals depth to specify that we want depth in the x-axis. Then we'll arrow out of those parentheses. We'll do plus stat bin, which says that this is going to be a histogram, and for the bin width, which is each bar, it will equal 0.3. And then lastly, of course, we'll do the GG title, which is my name, you do your name. Before I run this, like I've been doing, we'll call back the chart. So first run the diamond depth gets ggplot function, and then I'll call back. Oh, I made a little typo. So instead of diamonds, I said diamond s. So make sure you have a D in there, and then you run it, and then we'll call it back. And you can see in the bottom right panel, we have a histogram that shows a bell curve saying, you know, the count of diamonds that you get, there is, you know, a preferred depth that you find those diamonds at. It's a little bit more than 60, a little bit less than 65. So you're able to tell that insight from what we just created. Now we're going to create a bar chart using the ggplot2 package. So we will start by creating a new variable that will contain information about the bar chart. And then we will write a base function ggplot to specify the variable that has Google data, and put the date for the x-axis, adjusted close for the y. Then we will specify that we want a bar chart. So this is a little bit longer of a code, so I'm going to break it up in chunks. So we'll start by doing Google underscore bar chart. Then we'll do gets like we've been doing, ggplot parentheses. And this is kind of same as we've been doing previously. Data equals Google to specify the Google data set, comma AES for aesthetics, set X equal to date, comma Y equal to adjusted close, which is again ADJ close. Then we'll do plus, And this is where we specify that we want a bar chart. So we do geom underscore bar, and you put a parentheses, and we're going to do stat equals identity, because we have to put something in for stat. We're going to just denote that it equals identity, comma, fill equals steel blue, if I can spell it correctly. So what that says is we want the fill of each bar to be steel blue in color. Then we'll do a plus sign, and I'm going to shift down. You don't have to. Notice I didn't run the code. I just shifted down so that you can see the data set. Then we're going to do geom text, which will round the adjusted close data by 2 decimal places, and then put that value on top of each bar and specify the size that we want that text to be. And then we'll rotate it by 90 degrees so that we can read whatever that text is. So we'll use the geom underscore text function. And we do AES parentheses label equals round to round the data, parentheses ADJ for adjusted close, that's what we want to round, comma, digits equals 2. So round the adjusted close to 2 digits. Then we'll arrow out of 2 parentheses, and we'll do comma, and I'll stop here. I'll let everyone get up to date with where we are. I'll take a sip of water. So now we're going to identify the position that we want that text to be. So we'll do position equals parentheses identity, move out of identity, and then comma h just equals 0, comma size equals 2 for 2 pixels. We want that text to be 2 pixels, comma SRT equals 90. So that's rotating the data 90 degrees. And then we'll move out of that parentheses. We'll do plus. I'm going to shift down. Like I said, this is a long code, so I'll let everyone get up to date there. Lastly, we're going to set the theme to minimal. This is so that we can easily read the data that is on the chart. So for that, we do theme underscore minimal parentheses. And notice that I have a plus sign on the second row. So it's plus theme minimal parentheses plus, and then GG title. We've done this before, so I'll put Kevin for my name. You put whatever your name is. And then arrow out of that, I'll go down and I'll call back the bar chart. That way you can see if it works, if the code works. So before I run this code, I'm going to let everyone see it just one more time. Notice there's a plus sign at the end of the second line. So if everyone's ready, I'll run that, and then I'll call it back. And on the bottom right panel, you can see that we have the adjusted close on the Y, date on the X-axis, and we have a bar chart that has the values at the top of each bar. And so you can tell, halfway through 2016, what the values were for the adjusted close. You can see the data is trending up for the most part. Lastly, we're going to do a scatter plot. So while a bar chart, is nice, scatter plot is actually better for the ggplot function. So we're going to create a scatter plot using the Google data. And we will start by specifying to use the Google data, obviously, set date equal to X and adjusted close equal to Y. And then we'll specify the scatter plot function and then add a line to show a trend line in the data. So we'll do this by first creating a variable, Google underscore scatter plot. Then we'll do get, like we've been doing, ggplot data equals Google parentheses AES I'm sorry, comma, AES, parentheses, X equals date. So that date is in the X axis, and Y equals adjusted close. We'll arrow out of the parentheses. We'll do plus geom point. So this specifies that we want a scatter plot. And then we'll arrow out of the parentheses plus geom, geom underscore smooth. And then in this, we'll do method equals LM, and that denotes that we want a trend line. Lastly, we'll do plus. I'll shift down and I'll move over, and then we'll lastly put GG title parentheses, and I'll put my name like we've been doing. You put whatever your name is. So I'll give everyone some time to write that down while I put down the name of the scatter plot to call back. I'll arrow up to the code. I'll, accidentally shifted. I'll run that code, and then I'll run Google scatter plot. And then you'll see in the bottom right corner, we have a scatter plot with the Google data. And you can see, like we've been seeing in the bar chart, that the data is trending up, and you'll actually have a trend line to kind of see the average about how the close price is trending for Google. So that concludes the first part of the exercise for the Technical Development Workshop 1. Now Karina is going to walk you through the second half of the workshop, and then we'll come back to this file. So what you want to do is save the file where I just did in the top left panel, but don't close this window, because if you do, you'll have to reactivate the library packages. So make sure not to close this window. And without further ado, here's Karina.
Thank you, Kevin, for going through the exercise. It's time to do some clustering. I will need to install package for that. I'll write install packages, and it's called cluster, and I'll run that. Yes. And then while it's installing, I'll write library cluster, and then install it right on time so I can run it. Now it's activated. I'll need to make sure that my data will come out clean. So I will create a new variable, num data norm, and it will get as apply function. I will use air quality dataset. So as apply function, it will make sure that the quality of data is good, it will reduce redundancy, and it will scale it. I'll run that, and let me run air quality package dataset. This is how it looks like. And as you can see, there's 1 NA, 2 NAs, 3 NAs. Okay, this is not good. So I have to change that. So I'll do num, I'll call this again, and I'll write that this code, this variable, needs to get complete cases, which means that it will eliminate all the NAs. And then I will copy that again, paste it. Now it has clean data. I will also need to set a number of how many numbers, what is the maximum number of random numbers the R can generate. Yes, it is confusing. Let me show you an example. Let me generate a random number of 5. I'll run that, and it generated me -1.2 and etc. Let me generate a random number of 5 for x2. it's different. But what if I will set seed of this and I'll run code for x2 equals, as you can see, the number is the same because we ran a function set seed and we told the R that this is the only numbers you can run. So it makes sure that when you share your document with somebody else or when you run it again, you will get the same result. Clear that. And then I don't need x1. I don't need x2. We have a function for us that will analyze our data and set optimum number of clusters. So first I'll need to install one more package. Install packages nbclust. And then I will write library to activate that in nbclust. I'll create a new variable, optimum. It will get nbclust, which is a function. We'll select this variable. Distance is Euclidean. And then max number of clusters will equal to 12. And then method, its more common way to do that is k-means. Let's run that. And we have to wait. Well, it was pretty quick. It suggested us a number of clusters to be 3. Let's create a bar chart. I'll use bar plot this time. I will create a table because bar plot needs organized data, like in table. And I'll do optimum, which is this one. Optimum, and I will select a best number of clusters. Because if I run optimum here, best number of clusters, and it will select in here. And I have to specify that this is first row. And then for X label, I'll say number of clusters. And for Y axis, I'll say number of criteria. And one more thing, I will give it the title. Main equals number of clusters chosen by criteria. And I'll run that. So this is the output. I visualized what happened in optimum. So you can see it shows 3 is the best option. Next step is finding k-means, which is a common way of clustering where you divide a data in different groups. For example, dividing a number of customers based on their buying criteria. So k-means will help us to analyze these different groups. For example, what is the distance between a person and the center of their group, average center of their group, or what is the distance between these different groups. So first I'll create a new variable in the km, and I'll perform k-means function. I will select this data variable. So since optimum function told me that the optimum number of clusters 3 is the best, I'll use 3. Number of minimum clusters I want to be 1. and intermax is 30. So this function, what it does, it limits the maximum number the function will be doing, analyzing and putting data sets in different groups. So it does one round. It places the data set in different groups. And then it thought, let me do it again, double check. And then it probably moved the group a little bit. So it does the process 30 times. I will run that. And it's right here under data. And I will select fit km, and I'll select the size of each cluster. So I have 3 clusters, and I have 3 sizes of it. And if I open air quality again, so based off all of this, all of this information, and it placed to 3 different groups. And let's visualize it. First, I'll create data.cluster variable, and we'll get fit.km dataset, and I will select cluster. Run that. And then the last one is class plot. I will select this variable, and then I will select this one. So it will place the data set, and then it will create clusters and visualize it. Now these are 3 groups of clusters. As you can see, the distance between them, and then how it placed it. I'll pass to Safania to do exercise with clustering.
Hello guys, it's Stefania. So we're going to start the cluster part of the TD workshop. And what we're going to do is prepare data using Diamond datasets. And the Diamond dataset is a really large dataset. And if we try to run the whole dataset, it's going to return timeout because our computer can't process all the information. So what we're going to do is specify exactly 1,000 rows from the dataset, from the Diamond dataset to return. So we're going to work with just 1,000 rows. So we're going to start by calling the Diamond dataset. Actually, I'm going to show you the Diamond dataset. So this is the dataset. As you can see, there's 53,930 more rows in addition to this. So we're going to run that and get function head, and then write diamonds, and then say diamonds, and say we only want 1,000. Command return. So the data diamond set just popped up over here, and if you click on the grid, you can see the data. There's 1,000 entries. So we're going to go back and we're going to specify price and depth from the Diamond data set. So we're going to say diamonds, select diamonds, price and depth, command return. So if you go back to the tab, it will see just price and depth. And that's how we selected just those 2 data sets. So next, we're going to create a variable called num data norm. Num data. And then we're going to use function sapply. And what sapply does is take a list of matrix or vector data and return matrix or vector. So you need to do that in order to do clustering. So we're going to do sapply, and then diamonds and scale. Command return. So we just, what this code just did was reduce any redundancies in the data set. Next, we're going to write code that can eliminate null or NA from the data set. So we're going to use complete cases function. And what complete cases function does is tell R, select or give me only complete cases without any missing information. So we're going to do num data norm complete cases and then num data norm and then a comma, command return. So next we're going to do set dot seed, and what this does is generate a random sequence of numbers, and it ensures that we all get the same result. So that's what set.seed does. Command return. So again, this eliminates NA or null, and this reduces any redundancies. And then that is how we prepare data. So next we're going to find optimum number of clusters, and we're going to create a new variable called optimum and then assign it to nbclust function. And what it does is just analyze the data and suggest optimal number of clusters that we should use while clustering. So we're going to do optimum, assign it to nbclust num data norm, and then distance of Euclidean. So what Euclidean is just it's just the distance between clusters. Method k-means, command return. So next we have to wait for what we just did. We have to wait for it to run. Wait for the function to run, but we're going to just create a table in the meantime. Optimum best .nc. So what this does is just get the results from what we did in line 70 and create a table from that result. So it should be coming anytime soon. And then we're going to create a bar plot showing the number of clusters once we have all the, there you go. So we're going to command enter. So this is the table that we returned. So next we're going to create a bar plot with all the data. So bar plot, table, optimum, best, 1, comma, and then xlab. Xlab is just naming the x-axis and its number of clusters. And then we have to do that for ylab as well. So ylab is number of criteria. And then main is naming the bar graph chosen by criteria. Command return. Oops. You have to equal sign. Sorry, command return. Okay, awesome. So we got the output as bar graph. So if you click on zoom, you can view a larger version of it. So next, we're going to perform k-means clustering. and we're going to create a new variable and assign it to k-means. We're going to do fit.km and assign it to k-means. Use our variable num data norm 3 and start 1 and iterate to 30. Command return. So next, we're going to ask the size of each cluster. So we're going to do fit.km $size, command return. So this tells you the size of each cluster. Next, we're going to assign the cluster that we created before it to a new variable called data.cluster. And then lastly, we're going to create the actual cluster plot. So we're going to be using clustplot function and select a variable that holds our clean data. So clustplot, and then our variable that we created with the clean data and the new one that we created. Command return. So this is it. This is the output of clustplot that we created for cluster exercise, and you can save all the charts to a PDF file. So this ends the exercise of the cluster and cluster part of the TD workshop, and I'll hand it over to Karina to show you how to save exercises and submit the project.
Thank you, Stefania, for going through a clustering exercise. So how do you save all your data? You just run all of these codes. And then the output will be in images folder in this file. This is the deliverable I'm looking for. Basically, workshop 1 R, your first name, last name, and then TU AccessNet, which is TUA00000, and then your name on each chart. It's okay not to have name on the second one, and then your name on the third one, your name on the histogram, your name on the bar plot, your name on the clustering, and then it's okay if you don't have name on class plot because we didn't create one. I hope you enjoyed this workshop and learned something new.